Walter drives his bus with velocity given there, that velocity formula, where v of t is measured in feet per second, t is measured in seconds. Find Walt's displacement and his total distance traveled from t equals 0 to 8 seconds. Remember that displacement is how far you end up from your starting position, and it may be positive or negative, right or left. Distance traveled is always positive. It's how far you actually move during your trip, whether forward or backward. All right, how do we do it? Well, first step is find S, the position formula, by taking the antiderivative. So remember that over here I have the relationship. Remember position, velocity, acceleration. We take the derivative of position, we get velocity, derivative of velocity, we get acceleration. So backwards, the antiderivatives go back. So if we want to find position, and they're starting us with this velocity equation. So from velocity back to position, that's an antiderivative. So we take that velocity equation they gave us here, and then I did the anti to get position. So the antiderivative, you know what I did there? I just added 1 to the power, made it 3, and then divide by 3. And here this has a 1, add 1 to the power, make it 2, and then divide by the 2 right there. And then 5t, that's the anti, because the derivative of 5t will go back to 5, or negative 5t will go back to negative 5. So there's the antiderivative function. There's the position. That's going to give us the position of the particle at any time t seconds. So we'll know right where that particle is at any time t seconds. But then the second step, down here, is find when the velocity is 0, because that's important. That's when the particle stops. We got to find when is the velocity 0 and plug in only the positive time to the position formula. What am I talking about? Well, so I got to find when's the velocity 0. So I take the velocity. Here's the velocity equation, right? We have the velocity and we have the position. So right now I want to know when the velocity is 0. So come down here, I take the velocity equation, set it equal to 0. Well, how do I solve an x squared or t squared equation? The quadratic formula, negative b, plus or minus, etc., etc. So here it is. I plugged in. Here's the a, the b, the c, set equal to 0. Plug it all in. And then I went to Desmos and I got two answers, negative 2 and positive 5. We cross out negative time and only use positive 5. We can't go back in time. So we cross that one out. Positive 5. Here it is. Here's the Desmos work. I typed it into the formula right there. I'm showing the positive. I get the positive 5. If you make that negative right there, you get the negative 2 answer. We cross that out and don't care. So back to it. So then we found out that t equals positive 5. That's when positive 5 is when the velocity is 0, and now plug in only that positive time, again, we throw away negative time, to the position formula. So now there's 5 seconds. I'm going to plug that in now to the position formula right there. There's the position formula again, the one we found. Plug in your 5 right there. Hit the buttons on Desmos. Negative 22,9166. There's where I did that on Desmos right there. So back to it. So there's the position when the particle stops, when the velocity is 0, when the particle stops, there's where it was. There's its position in feet. Finally, find the ending position. And what's the ending? T equals 8, right? Because they told us in the beginning that we're going from t equals 0 to t equals 8. So it ends 8 seconds down the line. So we go, okay, so we found where it stops. The velocity was 0. Now we're finding the ending position. Plug in 8 again to the position equation. There it is, 888. Hit the buttons on Desmos. I got negative 2.666. Then, step 4, you can map the travel. So now we know the particle started off at 0. It went back to negative 22.9166 and stopped. Right there, it stopped for just a split second. It stops. How do I know? Well, that's what I did in step 2. I found when the velocity was 0. I took the velocity equation, set it equal to 0, put it into the quadratic, and found negative 2, cross out negative time, positive 5. So at positive 5 seconds, the object stops. And then I found out where it was at that time by plugging into the position equation, 5 seconds, and found out it was back 22.9166. So that told me, oh, it's back 22.9166 feet and stops. So it goes, it started at 0, at time 0. It started at position 0, went back 22.9166 feet. And then I found the final position is negative 2.6666. So that's to the right. So it must have gone to the right and finished at 8 seconds. Right? Stopped at 5 seconds, finished at 8 seconds. So there must be a map of its travel. So now here's the two questions. What's the displacement? Well, here, I didn't even write that in, but let me write it right here. The displacement is basically how far it fully traveled. Well, it's the ending point minus the starting point. How about we just say that? So where did it end up? It ended up at negative 2.6666 minus the starting point is 0. So the answer is negative 2.6666. That's how much it displays. That's feet. In other words, it ended up 2.666 feet to the left of where it started. That's its displacement. Like if I pick up the salt shaker and I move it all around the table and end up putting it just 3 feet to my left. In the end, it only moved 3 feet to the left. That's the displacement, how far it ended up from where it started, end minus start. So that's that answer. That's up here, displacement. Got it. Now, what's more tricky is total distance traveled. How do we find that out? Well, we have a map. We have a map of the travel. It went this way, 22.9166, because that's where it ended up. Now, how far was this leg of the journey when it came back? Well, to figure that out, just take the ending point here minus where it started, that little second leg of the journey. So the minus 2.666 minus the minus 22. Watch out. Minus a minus, going to plus, it ends up, that's 20.25. So then you just add those together, the 22.916 and the 20.25, and you get 43.166 feet. That's the total distance traveled, this leg and that leg. Again, how do we get the distance on that second leg? We just subtract the two spots. That's how you always get how long a section is on the number line. You just take where it ends minus where it started, that little piece of the journey. It ended minus where it started. Hit the buttons on Desmos. That trip is 20.25. The first part of the trip goes all the way to negative 22, so that's 22. Distance is just positive. We were saying how far. This distance plus that distance. There's the total distance traveled during the trip. And so there we go.